Hey everyone, this is DGB Exotics. My name is Daniel, and I just wanted to talk about a confusing gene in corn snakes known as Ultra. Now, Ultra, you're probably most familiar with it in the combination of Ultramel, and a lot of people have trouble understanding how it is inherited from the parents to the offspring. So, I wanted to do a representative demonstration of how this works. Now, let's say you have the sire and the dam of any pairing that you plan to do. These are normals. Yellow is going to represent the normal gene. Each of those parents is going to send a copy of their genetics to their offspring. So this is one of the babies they produce. The parents, of course, keep their copies. Each of these represents a gene. So in this case, we're talking about the normal color expression. So the parents have 2 copies of the normal gene. Now, let's switch over to AML. In this case, we have a normal parent and a normal appearing parent that carries the AML gene. So, the parents can send down either one of the genes that they carry, either copy of the genes they carry. So, in this case, the dad can only send yellow. The mom can send yellow or orange, being AML. So, you have a chance of the baby coming out with these set of genes. The babies can be totally normal, or the baby could wind up inheriting that copy of AML from the mom. It's about a 50-50 chance. All the babies are going to look the same, but half of them will be normals, half of them will be normals carrying AML. Now, let's change it up and say that the sire is also normal, carrying the gene for AML. So the parents both look normal, but the parents also carry a copy of the AML gene in their genetics, which means they can pass it down to their babies. So you have a chance that the parents each pass down their yellow copy. So from dad, from mom. The parents could pass down a yellow copy and an orange copy. Or in this case, it's equally an orange copy, the AML, or a yellow copy, the normal. So you wind up with the options being like this. Or each parent can pass down a copy of AML. This is why when you breed a normal that carries AML to a normal that carries AML, you have a portion of the babies that all look normal and a portion that look AML. So this is where the 66% comes from. When you get an animal that's 66% for a gene, heterozygous for a gene, that means 2 out of 3 likelihood of any one animal carrying AML in this case. All right, now that we got that crash course on how the genetics basically work, let's throw a wrench in all of that and look at the Ultramel gene. Ultra gene. So this would be a normal and this would be an ultra. Now, just for comparison's sake, that's orange. I should have used a different color. You know what? Let's use a different color because that's too close. Ultra. So, normal gene, ultra gene. The dad can only pass down yellow because he carries 2 copies of normal. The mom, this dam, can only pass down a copy of green or ultra. It's the exact same thing as AML. So, in that case, I am going to take a few steps ahead because, again, it's the exact same genetics. We're going to talk about how Ultramel. Nope. My bad. Ultramel, so that's 1 copy Ultra, 1 copy Amel, works with 1 copy Ultra, 1 copy Amel. Now, these babies, just like the normals, can only pass down 1 copy from each parent. So when you breed an Ultramel to an Ultramel, you have a 25% chance of homozygous Ultra. 50% of the babies are most likely going to be Ultramels, and then a 25% chance of Amels. That is because Ultra and Amel take up the same place on the DNA as each other. So, the reason that is called allelic. So let's say you've got your... Give me just a second. So, taking a step back to understand what allelic means, it means, now here's your little DNA piece, and here's also the DNA piece. This is just what it's supposed to look like, and this is just my representative example. So, let's say this spot on the DNA is where you can get normal, or you can get Amel. So this animal would be a normal het for Amel. This animal is an Amel. Ultra occupies, the Ultra mutation occupies the same place on the DNA strand. It's not here, it's not here, it's here. So this animal is an Ultramel. Now, most of your genes, this does not want to cooperate. Most of your genes that can make combinations are going to be in different places on the DNA. So this red piece, let's say, represents hypo. Hypo, let's make it a homozygous hypo for the sake of this demonstration. This is a hypo Ultramel. This is a hypo Amel. This is a hypo het for Amel, meaning that this, where this spot on the DNA that Amel is represented by the dominant normal colored gene. So you've got a normal looking animal in combination with the homozygous hypo. This animal is a normal het for hypo, het for Amel. I hope this is beginning to make sense. But that is why you can't, this is why, basically you can only have 2 copies of any gene. You cannot have 3. That's why you can't have the representative of normal and ultra and hypo. I'm sorry. That's why you can't have the representative of a normal het for ultra and Amel. You can only have an animal. Now let's say the animal, you can't tell what this other gene is because it's normal. In this case, if the parents possibly are ultra or ultramel or Amel or something like that, if there's any question, you'll often see Amel or ultra. So it's normal appearance, het for Amel or ultra. I hope this is beginning to make sense. Feel free to scroll to different parts of the video to get a better understanding of any part that I have discussed so far. Let's run this through one more time, and let's make it a little more complicated by saying we have a sire that is het for ultra, and a dam, the female, is het for Amel. she can pass down either a normal copy or an amel copy. So she has the possibility of producing, this pairing has the possibility of producing let me use the pen. This is from the male, and this is from the female. So this is a normal het ultra. The next baby, let's say, inherits a copy of ultra from the dad. And nope, not normal. And a copy of ultra of amel from the mom. So ultra from the dad, amel from the mom. This is your ultramel. Now, he sends down a copy of his normal, and she sends down a copy. He sends normal, she sends amel. This is a normal het amel. Lastly, he also sends down amel. Normal, sorry. And she sends down normal. So, you've got normal, normal, normal. That means this clutch, 1, 2, 3 out of 4 babies are going to look normal. Out of those, you have a 66 out of 3, 1, 2, 3 chance of those normal appearing animals of being either amel or ultra. But because the parents could have passed down any arrangement of this, oh my goodness, these do not want to stay put. Tic Tacs were not the best thing to use for this. Oh my goodness. This is going downhill fast. So, let's move this pairing, these babies, around so it's easier to see. This is an ultramel. This is your normal, normal, normal. Okay, so I hope this is beginning to make sense, because you can only have one copy of either, you can only have 2 copies of this particular gene. So again, to represent, normal from dad, normal from mom. Discard that. Normal from dad, amel from mom. Ultra from dad, normal from mom. And lastly, ultra from dad, amel from mom. This is your ultramel. Please let me know in the comments below if you have any questions about this. I know it can get confusing. This is almost a 14-minute long video, so I'm going to end it here. Let me know if you have any other questions. I would love to explain this. I will make another one in the future based off of your comments to hopefully make more sense of this if you still don't understand. All right, have a great day, everyone. Check out our Morph Market page for animals we have available, for corn snakes in particular. And have a great day, great night, great whatever. Have a good one.